Assalamu alaikum wa rahmatullahi wa barakatuh. Today we are having lecture number 3, where we are going to finish this chapter, States of Matter. So in this chapter we will be discussing or going through the effect of pressure and temperature on volume, and diffusion and a rate of diffusion. And lastly, I have attached in the last slide a practice sheet. If you will solve this practice sheet, so this is how you can assess yourself whether you understood the chapter well or not. So let us start with the first objective of this lecture: effect of pressure on volume. Pressure-volume relationship, when we know that that gases are compressible, so there is an effect of pressure on volume, and this is one of the gases law called Boyle's law, right? According to Boyle's law, volume of a gas is inversely proportional to the pressure exerted, right? To the pressure exerted. So we can say that V is inversely proportional to P, and the term should be at constant temperature. This is the condition, because temperature has also effect on volume, so we have to keep this variable constant. So we can also write over here, volume of a gas is inversely proportional to the pressure exerted at constant temperature, right? So if the temperature is kept constant, so volume is inversely proportional to pressure. As you increase the pressure, volume will be decreased. So you can see in this diagram that the pressure, there was a certain pressure on the gas. So gas particles are far apart and having a certain volume. When you increased the pressure, so volume has been decreased and particles became closer. If you draw a graph for this relationship, so the graph will be a curved line. So right as you are increasing the pressure, the volume is decreasing. So this is volume pressure relationship at temperature constant, right? Moving on, the next relationship, effect of temperature on the volume, right? So temperature volume relationship is also one of the gases laws, right? And the law is called Charles' law. So according to Charles, the volume of a gas is directly proportional to the temperature. So it means if you increase the temperature of a gas, volume also increases, right? But the temperature, for this relationship, pressure should be kept constant, right? So at you can say constant pressure, at constant pressure. So V is directly proportional to temperature at constant pressure. Look at the diagram. Pressure we kept constant. These arrows, they are showing pressure, so we are not changing pressure, but what we are changing from T1 to T2 means we are changing temperature. So volume has been changed. There was less volume when we increased pressure, so volume also increased. The piston went up to increase the capacity of the jar, and so this is how we can say that as we increase the temperature, if we double the temperature, volume will also be doubled. Right? And a graph between volume and temperature at constant P, it will be a straight line gradient. Now coming to the next topic, diffusion. What is basically diffusion? First of all, we should know very well about the Brownian motion, where we discussed earlier in previous lectures that particles they move randomly, especially of liquid and gases, or you can say fluids, because they move from one place to another. So their random movement is in a straight line, and they constantly move and change their direction when they collide with other particles or collide with the walls of the container. And this particular type of motion has been discovered by Brown, so that is why after his name it is called Brownian motion. You can see the particles, they are constantly moving in a straight line. When they collide, they change their direction, right? So diffusion is based on the motion of the particles. So what is exactly diffusion? Or how can we define diffusion? It is the movement of particles that allows them to spread out and mix with other particles. For example, we sprayed a perfume in the atmosphere, in the air. So what happened? The particles of perfume, they spread throughout the air particles, right, and mixed with air particles, and this is called diffusion. And diffusion can also be defined as, and diffusion is actually the movement of particles from a region of higher concentration to a region of lower concentration. So can you see in the diagram that for brown particles, the region of higher concentration is this, and they are moving here, which is the region of lower concentration for brown particles, right? And these grayish particles, they are moving from their the area of higher concentration to the area of lower concentration. So they thoroughly mixed with each other, and this is what exactly diffusion is. So these are the few points we should keep in our minds. Diffusion happens in liquids and gases, but hardly in solid, because the particles, they move, they slide past over, they randomly move in liquids and gases, but they do not move, they just vibrate in solids. That is why diffusion hardly takes place in solids, right? Diffusion takes place more quickly in gases than liquids because of the movement of the particles, because they move with a high speed, and we know very well that the kinetic energy, the particles of gas, they have the most, right? So when we compare the kinetic energy of the particles, so the kinetic energy of particles in solids is the least or very less, and liquid more than the solids, and gases, they have higher or the highest kinetic energy. So obviously they will diffuse faster than any other states of matter. Diffusion happens more quickly at warmer temperatures than cooler temperatures. So this is also a factor that at higher temperature, when we increase the temperature of a gas, the particles will diffuse or will spread more quickly, right? And another factor which affects the rate of diffusion is the relative masses of the particles. Heavier the particle will diffuse slower, a lighter the particle will diffuse faster, right? So let us consider an experimental demonstration. So we have a glass tube, and on the two ends we soaked hydrochloric acid at one end and soaked cotton wool, and cotton wool is soaked in ammonia solution. So what happens when we heat the glass tube? So particles of ammonia, they will start moving in the form of vapors towards the opposite end, and particles, so ammonia particles will, because this is the area of high concentration for ammonia and this is the area of high concentration for hydrogen chloride gas, so HCl. So we will see that which particle moves faster. So for that purpose we have to calculate their relative molecular mass. So atomic mass of nitrogen is 14 and hydrogen is 1, and there are 3 atoms of hydrogen. So 14 plus 3, so 17 is the MR of ammonia, right? 1 plus atomic mass of chlorine is 35.5, so 36.5 is the atomic mass of HCl. So we clearly see that the MR, or relative molecular mass, of hydrogen chloride is more than the twice of ammonia particle, right? So obviously lighter the particles, if you consider the race in athletics or in a competition, so okay, so lighter, or you can say the slim athlete runs faster, right? So similar the case is here, that lighter particles, they diffuse faster there, right? So when the time ammonia particles reach this point, HCl could hardly reach at the same point because it moved slower because of greater relative mass, or because of heavier particles. So what is the indication that when they react together, ammonia particles and hydrogen chloride particles, then when they collided with each other, they reacted to form ammonium chlorides, which appeared in the glass tube as white ring shaped fumes. So this is basically how we can know that in the same time ammonia moved longer in the glass tube, whereas hydrogen chloride moved shorter, because this depends upon their relative molecular mass, right? So this is the worksheet which you have to solve. So just take the screenshot or however you want, and if it will be encouragement for me if you solve and write in the comments. So thank you very much. Inshallah, in next video we'll start chapter number 2 of IGCSE syllabus. So till then, wassalamu alaikum wa rahmatullahi wa barakatuh.